So I want to tell you a story, a true story, where when I started my PhD, I came to my PI, Kobe, and I told him, listen, I'm really into cancer research, and I would like to have one of the projects in the PhD connected to cancer. And he said, yes, of course, I have this amazing idea for you. But listen, I have another project. It's about tooth enamel, and I need someone to do it, to finish it. It's like a half a year of work, and then we can publish. And then I thought to myself, wow, okay, half a year I can publish? Yes, of course. 6 years later, the cancer project totally failed due to technical problems. And here we were able to find a new disease. So I'm here to tell you that, first of all, you never know where life will take you, especially science. And I'm also here to tell you how we discovered a new disease where our own body attack the developing teeth enamel. So enamel is the white hard layer that covers our teeth. And it happens in people that suffer from autoimmune diseases. Now, autoimmunity is a situation where our immune system attacks our own bodies and own cells and tissues. It is like a friendly fire, if you may. And one of the diseases where it's happening, it's actually celiac. So celiac is an autoimmune disease. It is happened due to exposure to gluten, and it caused the immune system to attack the walls of the small intestine and totally destroy them. And it's causing problems in the patients of nutrient absorption. And apparently, surprisingly, 20 to 50% children with celiac, when their permanent teeth erupt, the enamel on the teeth is destroyed. It's not even developed properly. And no one knows why. What's going on there? But before I'm going to tell you why we think it's happening, I want to tell you about enamel, how it is developed. So imagine a building needs to be built, okay? So how would you go and build the building? First, you need to build a scaffold, right? You need a scaffold for the builders, the workers to climb on it and assemble all the wood, the cement, the bricks in order to build the building. And once they will be done and the building will stand, they will go home. They will leave the site. A very similar process happens in our body. But here, the workers are proteins. And these proteins have the ability to form a scaffold for mineral binding. So these proteins can bind all kinds of minerals, such as calcium and phosphate, and organize them in a mineral layer, which is the enamel layer. And like the workers, when the proteins are done, they go home, they degrade, and we're left only with the mineral layer. So this process is called amelogenesis, the process of enamel development. So scaffolding, mineralization, and that's it. Once the enamel is formed, it cannot be rebuilt again, at least in humans. And how does it look under the microscope? Like that. Beautiful, organized structure that gives the enamel, this organization gives the enamel its strength and makes it one of the body's strongest materials. So what happens when the enamel doesn't develop properly? It looks like that. And it is called enamel hypoplasia. And it's characterized by a thin or even absent enamel. And patients that suffer from enamel hypoplasia suffer from aching teeth, and they have problems with eating, they're sensitive to temperature, and you can imagine the cosmetic effect and the effect on their self-esteem. So back to our children. Again, no one knows why children with celiac develop this enamel hypoplasia. So because celiac is an autoimmune disease, so we said, okay, so the immune system, it's a good place to start. And we decided to focus on a part of the immune system called antibodies that you already heard here, but I want to tell you that antibodies are small proteins that has this amazing ability to target and bind their target in a very specific and efficient way. So we asked, can antibodies somehow interfere with the process of enamel development? So to do that, the first thing we did, we checked if the patient, the celiac patients, have antibodies against enamel, or we call them enamel-specific antibodies. So let me go through this graph, okay? So we performed an experiment where we took bloods from children with celiac. I know it sounds bad, but it's for science. And here on the y-axis, you can see the antibody levels. So here are low levels of antibody, high levels of antibody. And of course, we had our celiac patients and the control group. And when we checked for their antibody presence, it looks like that. So each dot here is a patient. So you can see and appreciate that the majority of the patients, the children, had high levels of antibodies against enamel. But can these antibodies harm or interfere with the enamel development? So for that, we performed the next experiment. So we isolated these enamel-specific antibodies, and we injected them into mice. And of course, we had a control group of just plain antibodies that we injected the mice. And then we looked under the microscope at the mice enamel. So the control group enamel looks like that. Beautiful, organized, healthy enamel. And what about the mice that were injected with the enamel-specific antibodies? A scrambled egg. It was disorganized, just a mess. So we concluded antibodies can indeed interfere with enamel formation. And what we think is happening is that these antibodies can actually bind to the worker proteins and block their ability to bind minerals, and by that to set the mineral layer. It is like if someone will come to the builders and tell them, now you can only build the building with one hand or without your leg. So you can imagine how the building would look like, right? So we named our new disease with this catchy name, autoimmune amelogenesis imperfecta, which is, let me translate. So imperfecta, it's imperfect. Amelogenesis is the process of enamel formation. So imperfect enamel formation, and autoimmune because it's involved the immune system. And I told you it's in celiac patients, but wait a minute, Yael, you also told us that celiac is a disease connected to the small intestine, the gut. What is the connection between the gut and the teeth? What is going on here? So we think that it's connected to the fact that the inflammation in the gut, in the small intestine of the patient, that can, much like a wildfire, can spread to other parts of the body. So actually the antibodies are generated, the enamel-specific antibodies are generated in the small intestine, and then they can migrate to the gum where the enamel is being developed and interfere the process over there. But it's all matter of timing, like life. So if the antibodies are generated before the age of 7, it will interfere the enamel formation, and the patient, when the permanent teeth will erupt, they will be damaged. But if these antibodies or the disease will develop later in life, in adulthood, after the enamel already been formed, it will not affect the teeth. So again, it's all about timing. And we believe that's the reason it's happening only in 20 to 50% of children with celiac. So we hope that our new discovery will help to better diagnose and treat people that suffer with enamel hypoplasia to give them a better quality of life. And with that, I would like to thank all of our collaborators around the world. This was like a huge effort of many labs around the world. I would like to thank my mentor, Kobe, of course, and my beautiful lab members from present and past, and our fundings, and for you, for your listening. Thank you so much.